NOAA is preparing for a milestone satellite launch in 2024. GOES-U will be the fourth and final satellite in NOAA's latest generation of geostationary operational environmental satellites called the GOES-R series, the nation's most advanced weather observing and environmental monitoring satellite system. GOES satellites orbit 22,236 miles above Earth's equator at speeds equal to its rotation. This orbit provides continuous coverage of weather systems as they develop and move across the Western Hemisphere. GOES-U, which will be renamed GOES-19 when it reaches orbit, will replace the current GOES-16 satellite in the GOES-East orbit. In this position, GOES-U will continue GOES-East's legacy of keeping watch over the contiguous United States, Central and South America, and the Atlantic Ocean. Like the three other GOES-R series satellites already in orbit, GOES-U will provide near real-time, high-resolution imagery that will deliver critical information for weather forecasts, severe weather prediction, lightning detection, space weather, and tropical cyclones spinning in the Atlantic Basin.
It's going to be great when we get into the orbit of GOES East, because you'll be able to see, we'll start seeing the continental United States, but also out into the Atlantic to the African coast. Because if you think about it, working at the Hurricane Center, as I did, you need to be able to see some of the earliest initiation of some of these tropical systems.
And like the rest of the GOES-R series satellites, GOES-U will include the Advanced Baseline Imager, or ABI. It is the primary instrument NOAA uses to image Earth's weather, climate, oceans, and the environment from geostationary orbit.
Yeah, ABI really rocks. ABI is the primary camera on the GOES-R series, and it has a very large focal plane, and what that does for the instrument is it can look at very wide areas of Earth, and so because it can do that, it can scan very, very fast. What that means for the forecasters is they can look at a storm or other area of interest as often as once every 30 seconds. And when you can do it that fast, the forecasters are really seeing that data in real time.
Yeah, the early detection is everything, and having the instrumentation and especially the rapid scan to be able to have information quickly, because we have something that is such a challenge called rapid intensification, where a hurricane, just a band of clouds, become a strong system so quickly. So the more information and the more data we get, the quicker we get that information, the better we can do making that forecast and getting that information into the models for a better forecast. So having that rapid information and clarity that we're getting in the new instrumentation is just a game changer for the forecasters.
And along with the other GOES-R series satellites, GOES-U will have the Geostationary Lightning Mapper, or GLM, the first operational lightning mapper flown in geostationary orbit. GLM identifies the location, frequency, and extent of lightning over the Americas and surrounding waters, which can help forecasters understand how thunderstorms and tropical cyclones may be changing in intensity. And since its inclusion as a part of the GOES-R series satellites, GLM has continued to provide new insights.
And it could actually distinguish between sort of your average lightning strike and the ones that are more dangerous, the ones that are continuing current, and those are very long lightning strikes that are most likely to cause a fire.
Having technology in the GOES satellite, whether it's GOES-R or GOES-U, and future technology, early detection is everything. And we think about a satellite, the first thing you think of is a cloud. We see more than clouds, and lightning detection is a key to some of our early warnings for the fire weather community. So a lightning strike in a dry area in a time of the year that could cause a fire, that's an indicator to us that there could be a potential fire started.
Along with this suite of instruments on board NOAA's other GOES-R series satellites, GOES-U will carry something new when it launches, a critical space weather instrument called the Compact Coronagraph 1, or CCOR-1. CCOR-1 will be the third solar instrument on the satellite, and it will image the outer layer of the sun's atmosphere.
The compact coronagraph is a solar telescope that blocks the disk of the sun, so the main ball of the sun, so that we can look at the fainter outer atmosphere of the sun called the corona. And that's where extreme space weather events originate.
Being able to monitor the sun's corona helps scientists detect and characterize coronal mass ejections, that can spark geomagnetic storms here on Earth. Those are the costliest type of space weather events and can cause widespread damage to power grids, satellites, and communication and navigation systems.
It's very important for us to measure space weather effects and be able to model and provide warnings, forecasts, and alerts for space weather to protect our technological society. Basically, extreme space weather can touch all aspects of our economy and life and property here on Earth. I'm extremely excited about the compact chronograph that we're going to fly on the GOES-U satellite. This is a game changer for our forecast capabilities here at NOAA in the Space Weather Prediction Center. Having that data allows us to more reliably predict when these large solar storms are how they propagate towards Earth and whether or not they're going to affect us here on Earth in a significant way.
With CCOR-1 and 6 other high-tech instruments on board, GOES-U will continue NOAA's legacy to help scientists and forecasters understand, monitor, and predict our changing environment from the oceans to outer space. The GOES series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.